Hello, hello, hello. Okay, hello, hello. I think that now it should be fine. Can somebody confirm here in the chat? Hello, hello, hello. Yep. Okay, perfect. Yeah, I don't know what happened. Something was unconfigured here in OBS, but yeah, we are back. We are back. So yeah, I just was saying that hello everybody. Welcome to this new open class. We are today in open class number 168 already. And I was saying as well that today we are going to have a special class. It's not going to be as usual because we are going to be talking today about ChatGPT and how you can use it in different ways in order to help you in your process of learning ROS2 in this case. All right, so now that we jump into the class, you will see how we are going to structure it. But yeah, let's not lose any more time then, and let's get into it. So I'm going to share right now my my screen so that we can get started. Let me go for it right now. Yep, here we are. So, PC. Okay, let me make sure. Yeah, the sound should be good now. Let me, please, let me know if you can still hear me. I think that it should be working properly for what I can see here. But if somebody can confirm me in the chat, that would be great. It is good now. Okay, perfect. Then let me move here to the live class page so that I can have the chat here as well. So yeah, hello everybody. Hey, hello to Song, Dave, Daniel, Lujiang, Michael. Hello everybody. And yeah, so let's get started. Then I don't know if you are new to open classes. If not, in any case, if there is somebody who is attending for the first time to these open classes, let me explain, as always, what is the process. So the first thing that all of you need to do is to get today's rosject. So how can you do this? Very, very easy. It's just by clicking on this button that you have right above the chat, which says fork and open the class rosject. Okay, so I'm going to click here myself right now. There we go. And by clicking this button, this is going to basically generate a copy of this rosject into your account, into your workspace. All right, and you are going to have this project forever. Yeah, so if you copy it now, you are going to have it forever. So you are going to be able to open it next week, next month, in case that you want to review anything. So so yeah, that copy is going to be for you. And also, as you can see, this is going to redirect you to the rosject page, which is the one that it's loading for me right now. It might take some seconds, maybe up to 1 minute to fully load. And yeah, so as you can see here at the right side, you have the streaming area with the live stream video, the chat, just in case that you want to comment anything, make a question, etc. All right. Then yeah, so please, all of you, click on the button so that you get a copy of this rosject, and you come here to the main rosject page. And yeah, just wait a few seconds. It shouldn't take too long to fully load. Then yeah, so as you probably all of you have already noticed, these last months, weeks have been crazy, especially in terms of AI and ChatGPT. All this is getting a lot of attention. Every week, every day, almost new tools are appearing. So yeah, I wanted to do this class in order to provide some hints, let's say, some advice on how you can use ChatGPT in this case in order to improve, to boost your ROS2 learning. So Let me start by saying that I'm not an expert in ChatGPT at all. So yeah, I'm just going to give you some hints that I think that can be useful, especially for beginners. Okay. So yeah, as you can see, my rosject has already loaded. Once it is loaded, you should see here the notebook, which is, it should be automatically opened, as you can see in my case. And basically here in this notebook is where you are going to find all the instructions for today's class, all the different codes, programs that I'm going to be using. So you are going to find everything here, all right? Then please let me know if the rosject has loaded for all of you already, so that we are all in the same page and we can move together. Not yet, says Lautaro. Okay, don't worry. If it's not loaded yet, it's going to load in the next seconds. It has loaded for Al Jones. Downloading also for Michael. Okay, great. So I can see that it's being loaded for all of you. Then let's get started. So yeah, then before we actually get started, we are going to launch a simulation, okay? So we are going to be working with a ROS2 simulation today, and we are going to be testing different codes into this simulation. In this case, the simulation is going to be of a Turtlebot 3, okay? Here I can see that the instructions, however, are not correct. So I'm going to show it to you right now how you should do it, okay? Then the first thing that you have to do is to open a shell, all right, a new empty shell. And this is done by clicking here in the first icon that you have in the bottom bar. It says web shell. You can click here and this is going to open a new blank shell, all right? This is a regular Linux shell where you can type commands. And then once you have your shell opened, you're going to go, instead of Robotics ROS2, it's actually T3 Foxy, okay? So CD ROS2 workspace SRC T3 Foxy. You're going to click here. Yeah, so actually the folder, it's called T3 Foxy, but actually if you check with a Git status, you're going to see that we are actually in the Humble branch, okay? So this rosject is based on ROS2 Humble. We are working on ROS2 Humble right now, okay? Just if you are wondering, we are going to be working with ROS2 Humble, which is the latest stable distribution of ROS2. And then as for the next command, instead of this, we are just going to run the following, which is start sim, okay? Let me even copy these two commands here to the chat so that you can have them. Okay, so CD ROS2 workspace SRC T3 Foxy, and then we are going to run this command, start sim.sh. So I'm going to right now copy and paste the command here to my terminal and run it. There we go. You are going to start getting here a bunch of log messages, and then eventually you are going to see that a gazebo window like this one is going to pop up. Yeah. Now here is where you are going to be able to see, to visualize the simulation. Okay. Let me wait a few seconds. There we go. Then if everything, if the simulation is loaded properly, you are going to see something like this, an empty world, and here in the center, you can zoom up. You are going to see here the Turtlebot 3 robot, right here in the center. Yeah. So let me know if the simulation has loaded properly for everyone. Because yeah, while creating the class is actually, yeah. So in some cases, maybe you get some kind of gazebo error, okay? and you don't get to see the simulation. Process has died. Okay. In case that you are getting an error, don't worry. All you have to do is to Control-C here, okay? Control-C in the terminal to stop the process. You Control-C here. This is going to stop the process, as you can see. And you have to close as well here, the gazebo window, okay? Come here and close the gazebo window. Close it. Sorry. Just close the window like this, okay? And then just launch again the command, okay? Just run it again, and this second time it should work okay. All right? I am running it here a second time. Oh, I got the error now. I think that this is the same error that Michael was getting now, right? So what I'm going to do is just stop it, as I was telling you, stop it here, close the window, okay, and run it again. There we go. Now it's going to appear correctly. There you go. Okay, so Michael says mine is working now. Perfect. Okay, so at the end, as I was saying, you should get the simulation like this. Okay, an empty world with a Turtlebot 3 robot here in the center of the simulation. Yeah. Has everybody loaded the simulation, the gazebo simulation? Yes, no. Yes, 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 all loaded. Okay, perfect. Perfect. Then we are ready. We are now ready to get started. So let's go for it. Then I assume that probably everybody who is here in the open class knows already what ChatGPT is and has heard about ChatGPT. But in case that some of you have no idea at all about what I am talking about, what this ChatGPT is. So basically, as I was saying, I'm not an expert in ChatGPT. I'm going to try to explain it in simple terms. But basically, ChatGPT is an application. It's a chatbot, yeah, that is able to answer almost any type of question. Yeah, so you can make questions to this ChatGPT, and ChatGPT is going to answer to you. It's going to provide you an answer. It's a chatbot, yeah? And actually, ChatGPT is an application which is built on top of GPT, yeah? Okay, so actually it's an application, a product, let's say, yeah? Which is based on, it's built on top of GPT 3.5. In this case, yes? And what is GPT? Well, basically, GPT is a language model, okay? It means generative pre-trained transformer, okay? And this language model, GPT, has been developed by the guys at OpenAI, okay? Yeah, so are you familiar with ChatGPT, with GPT? Have you heard about it? Have you even used it? Yes, not at all. First time that you hear about it? Michael says, have used the trial for some times. Okay. Andrea says yes. Yes, also Al Jones. Okay. Then, yeah, so basically this GPT is a language model, but it's not exclusive to human language, let's say, okay? So you can ask to this ChatGPT any question, and it's going to, GPT is going to process all the words, and it's going to answer you in a very human-like fashion, okay? But this is not only exclusive to human language, but also to computer language, okay? So ChatGPT can also understand and produce computer language, so code, basically, programs, okay? Then this is what we are going to be focusing on on today's class, of course. And here I have left you a link to a podcast that we did some weeks ago in our Robotics Insider podcast, where we were discussing about ChatGPT and how it is going to affect robotics, etc. So I left you the link here, just in case that you want to give it a look, okay? Where me, myself, and some of my colleagues here at the Construct were basically discussing about this tool and how it's going to affect, how you can use it in robotics, etc. Yeah, so you have the link here in case that you want to check it out. But now, what brings us today here to this class is how can ChatGPT help you in your ROS2 learning, okay? So there are many different ways in which you could use ChatGPT to help you in your ROS2 learning. It has many different applications, but I would like to focus on three main points. One, it can help you to explain complex codes in a simple way, okay? This is one use case, one possible use for ChatGPT in order to help you in your learning process. Yeah, so it can understand complex codes and it can explain them to you in a simple way. Yeah, which is very interesting. Point number two is it can help you find bugs in your code or optimize your code. Okay. In today's class, we are going to focus or check a couple of examples about finding bugs. So you can provide a code to ChatGPT, and then ChatGPT is able to analyze this code and find bugs, issues, potential issues in this code. Okay? And then finally, last point number three is that it can create code for you. Okay? So all this has some drawbacks, okay, that we are going to also be checking today, and we are going to see it actually in the examples, okay. So ChatGPT is a very powerful tool. Let me say this now. It's a very powerful tool, but it's not perfect, okay. It's always going to require human supervision. All right. And you are going to see it in today's class as well. Then, let me also comment about this tool that we have recently added. So in the construct, in our platform, we have recently included this button here, which is this AI code assistant. Okay, I don't know if you noticed it before, if you have even used it, no, yeah, but it has been added recently in the last weeks, and it has very interesting uses, all right, and I'm going to show it to you today. Yeah, so let me also tell you that for free users, the usage of the AI code assistant is limited to, I don't know exactly the number, but maybe you can use it up to 5 times, something like this. All right, this is for free users. For people who is subscribed to our academy, to our platform, you can use it as many times as you want. All right, then let's start with practice. Okay, I think that the proper introductions have been already made. We have introduced what is ChatGPT, how you can use it in order to improve, to boost your ROS2 learning process. We have seen some of these main points, and now we are going to see some examples of each one of them. Yeah? So we are going to start by the first one, which is, it can explain complex codes in a simple way. Yeah, so we are going to see this first point and check a couple of examples. Then for this, we are going to use the AI code assistant that we have here in the construct. Yeah, so how you can open it, how you can use it, very simple. You just click here, and as you can see, a window is going to pop up, okay? Then how to use it in order to explain code? Well, basically, as you are going to see, you have a box here where you can copy, well, you can write, but you can, of course, copy and paste code into this box here, okay? Then this is what we are going to do right now. We are going to check a couple of examples, first of all, which I have picked from the ROS2 Basics in 5 days course. Yeah. So all the code that we are going to be analyzing here, all the examples are basically based on this course, on this ROS2 Basics in 5 days. I have also left the link here so that you can check it out. Yeah. Then the first sample code is this one. Yeah. This is the sample code number 1 that we are going to analyze. And in this case, this is a pretty simple, basic code. All right. So we have a class, a simple publisher class, which is initializing a publisher. Okay. That publishes into the command belt topic. Okay. We are also creating a timer here, which we are executing periodically in order to publish velocities to the robot. Okay, we are publishing a linear velocity and an angular velocity. Okay, so we as humans can obviously analyze this code, but here what I want to test, to show to you is how to do it with ChatGPT. Yeah, so let me select the code that I have here. I'm going to copy it. Okay. Control C with the shortcut, you can copy it like this as well. And then I'm going to come here to the AI code assistant and paste the code here. Yeah, I have pasted the code here. And then once I have pasted the code here, I'm going to click on the explain code. All right. Then as you can see, it's going to take some seconds. It's analyzing the code. And there we go. Here I have the explanation of my code. So let's check it out. Let's see what ChatGPT says that this code is doing. So it says, this code creates a ROS2 node that publishes a twist message to the command belt topic every 0.5 seconds. The twist message contains linear and angular velocities. The linear velocity is set to 0.5 and the angular velocity is set to 0.5. The node is created using the RCLPy library and the node class. The publisher is created using the createPublisher method and the twist message type. The timer is created using the createTimer method and the timer callback method is called every 0.5 seconds. Yeah. So far, as you can see, ChatGPT is right. Yeah. So we are creating a publisher that publishes twist messages. Yeah. A publisher that publishes twist messages, and it's publishing these to the command belt topic, of course, every 0.5 seconds. Yeah. So we are publishing to a command belt topic every 0.5 seconds because this is the period that I have here set for my timer. Yeah. So this function is going to be executed every 0.5 seconds. Therefore, I'm going to be publishing velocities every 0.5 seconds. Yeah. What else it says? The timer callback method creates a twist message, sets the linear and angular velocities, publishes the message, and logs a message to the console. Yeah. And so the timer callback function is doing all this. It's creating the twist message, it's giving it values, it publishes the message, and it prints a log message at the end. Then the main function initializes the RCLPy library, creates the simple publisher node, spins the node, destroys the node, and shoots down the RCLPy library. Yeah? So we initialize the RCLPy library, we create the node, we spin the node, we destroy the node, and we shut down the RCL-PI connection. Okay? Yeah, then we can run the code. You can run the code if you want, and you are going to see that this is what it is doing, basically. Yeah? Then, okay, but this is a pretty simple code, right? I mean, it's not that complex. What if we try with a code which is a little bit more complex? So here we have sample code number 2. And in this case here, what we are doing is to implement an action server. Okay? This code, this one, also this one, they are all examples from the ROS2 Basics course. Okay? All these are example codes that you can find in the ROS2 Basics in 5 days course, right? Then here we are going to try to analyze this code for an action server, which is a little bit more complex. Here we have more methods, we are dealing with an action, so it's not as simple as just a plain publisher, okay? Then let's now select all this code here. The code for the action server, I'm going to copy it. Let me go back here to the code assistant, remove what I have currently, paste, Control V, paste the new code, and again I'm going to hit on the explain code button. There we go. Let's see what ChatGPT tells us now. Okay. So it says, this code creates an action server for a Turtlebot 3 robot to move to the left for a specified number of seconds. Okay? So this code creates an action server to move the robot to the left for a specified number of seconds. It says, the action server is defined using the move action message. Yeah? The move action message, which is this one here. Okay? Which includes a request for the number of seconds to move and a feedback message to indicate the progress. Okay? So right now, I can come here. Open a new shell. Right here I have just opened a new shell. Okay? So let me source the ROS2 workspace. And I'm just going to check this message, ROS2 interface show, and this is T3, where it is, again, move. There we go. Okay, this is the request with seconds. It contains a feedback message, and it also contains here a result with the status. Okay. Then it says, the execute callback function is called when a goal is received by the action server. Yeah, so when a goal is received by this action server, this function, execute callback function, is called, is triggered. Okay? Let's keep going. Then this execute callback function, it sets up a feedback message and then moves the robot to the left for the specified number of seconds using twist messages published to the command bell topic. Yeah? So it says that it's setting up a feedback message, so we can see here, and then it moves by publishing to the command bell topic, yeah, for unspecified number of seconds. Okay? Let's keep going. After the movement is complete, the goal is marked as succeeded and a result message is returned indicating that the robot moved for the specified duration. Yeah? So after the movement is complete, the goal is set to succeeded. And what else say? And a result message is returned indicating that the robot moved for the specified duration. Yeah? And the result message is returned indicating that the robot moved for the specified duration. Okay? And then finally, the main function initializes the ROS node and spins the action server. Yeah? So yeah, the explanation, I mean, it's perfect, okay? So, as we can see, it can also understand more complex code and explain it step by step in a pretty simple way, okay? So, well, actually, let's test this. Let's test this code, okay? Because here ChatGPT is explaining us that it does this, but let's actually test it and verify if the code actually works like ChatGPT says. So for this, I'm going to execute these two commands. First of all, I'm going to start the action server here in a shell. Okay, so here we start the action server, and then I'm going to open another shell here in order to call it, okay? In order to send a goal to this action server. So now I can run a ROS2 action list. I'm going to see that the action server is listed here. And then let me source. And I'm going to send the following message here. Actually, I think that here there is one. There we go. Yeah. So ROS2 action, send goal. We send a goal to our action server using the move type, and we specify 5 seconds in this case. Yeah. In the goal request, we are specifying 5 seconds. So the robot should turn to the left for 5 seconds. Then let me send the goal and see actually what the robot does. Okay, it accepts the goal and it starts moving and turning to the left for 5 seconds. Okay? Yeah? Oops, sorry. So far, so good. Are you following? Yeah. So basically what we can see is that ChatGPT can be useful for trying to understand maybe complex codes, yeah, that on a first look we cannot understand. Okay? So this is a very interesting feature that you can use in order to boost, to improve, to help you in the process of learning. Yeah? So in the case of the courses, for instance, all the codes that you are going to find are already explained to you in the course. Yeah, but yeah, let's say that you start working on a new code from an external repository, then you can use this tool in order to make ChatGPT explain you in a simple way what is the code? What is the purpose of the code? Okay? Then let's check out a second example, which is to find bugs or optimize code. Okay? In this case, we are going to focus on the first one, which is to find bugs. All right? Then how this works is pretty similar to the tool that we have used so far. Yeah, this is also incorporated inside the AI code assistant, as you can see down here. Yeah, you have the option explain code, find bugs, and optimize fix. Okay, so for this example, for this class, we are going to check out an example of find bugs. Okay. Then let's set up the following scenario, okay? Let's imagine that there is an exercise, which is a very typical beginner exercise that lots of our students are doing, yeah? Which this exercise asks the student to create a program that analyzes the frontal value from the robot's laser, okay? So this this turtlebot robot has a laser mounted here on the top. So create a program that analyzes the frontal value from the robot's laser. If it doesn't detect any obstacle closer than 1 meter, the robot will move forward. If it detects an obstacle closer than 1 meter, the robot will stop. Okay? So basically, this program is going to make the robot move forward until it detects something, an obstacle, which is in front of the robot and which is closer than 1 meter. In that case, the robot is going to stop in order to avoid crashing against this obstacle. Yeah? This is a very typical exercise for beginners. So let's imagine that we have an exercise which asks us to create this program, okay? Then this is the code that the student, in this case it's me, okay, I have created. Yeah. So you can have a look at the code for this exercise. So I am creating a publisher to the command bell topic to move the robot. I am subscribing to scan. Okay, I am subscribing to the laser data in order to get the laser readings. I am creating a timer as well for the logic. Then I have a laser callback where I am getting the value for the forward reading of the laser. And then in my timer, I analyze this laser forward value, right? So if the value is higher than 1, I'm going to move the robot forward. So I'm going to send a linear velocity in the x-axis to the robot. If the value is lower than 1 meter, yeah, so else, yeah, if this is not the case, which means that the value is lower than 1 meter, then I'm going to stop the robot by setting the velocities to 0. Okay? So, yeah. Let me set up the simulation here. So, there we go. Okay. So, for this example, I need to place an obstacle in front of the robot, right? So, for this, I'm going to use Gazebo directly, okay? I'm going to use this tool, this Gazebo client, yeah, in order to spawn here a cube in front of the robot, okay? I'm going to spawn it somewhere around here, let's say, and let me as well rotate it, yeah, like this. There we go. I'm putting this obstacle here. I'm going to move it a little bit to the right as well, so that it is right in front of the robot. We move it a bit here. There we go. Okay. So I have placed an obstacle now right in front of the robot, okay? So the expected behavior of my program is that the robot is going to start moving forward, yeah? Then when it detects that it's closer than 1 meter to this obstacle here, the robot should stop, okay? So, put this small again. There we go. Okay. Let me close. Yeah, let me go back here to the first shell. So now, let's try our program, okay? Let's try our program. Well, let's compile, first of all, not here, but in the ROS2 workspace. We can compile here our code. So, yeah, in this case, I have, sorry, I have prepared some programs here in this rosject, okay? In order to check them out, you have to open here the code editor, okay, which is the second button here in the bottom menu. The second icon, this is going to open the code editor for you. Here we have it, okay? Then here you are going to be able to see, using a graphical interface, the different workspaces and programs, codes that, that you have inside the rosject. So in this case, if you go here inside the ROS2 workspace to the SRC folder, you are going to find here the T3 Foxy, which are all the packages and everything needed for the gazebo simulation. And then you can see also here this ROS2 package, which is called GPT tests. Yeah? Inside here is where I have placed all the codes. Okay? In this case, the code that we are working with is this detect obstacle. Okay? That we have here. You can open it and you can check it out here in the IDE if you want. Okay? Then, all right, so here we have compiled. So let's source, and let's run our program, okay? Let me open the simulation so that I can see what happens in the simulation. And then in order to run it, you can execute ROS2 run GPT tests, and then it's, how it is, it's a detect obstacle, so it's going to be detect obstacle node probably. There we go, okay? So if we execute this, what happens? Okay, so here we are getting an error, attribute error, exercise 3.1 object has no attribute my callback. Okay, so here it's complaining about something. So let's do one thing. Let's try to copy and paste the code and ask ChatGPT what does it find here, yeah? So I'm going to copy the whole code here. I'm going to go to the AI code assistant, and here, again, let's clear the current code and paste the new one. Paste, there we go. And now I'm going to say, hey, find box in this code. There we go. Let's see what ChatGPT tells us. Okay, so here we can see a list of different errors. So let's start by the first one. Here it says, the callback function for the laserscan subscriber is named myCallback instead of laser callback, which is causing the laser forward variable to never be updated. Yeah? So here it's telling me that my laserscan subscriber, which is here, yeah, my laserscan subscriber, the callback function for my subscriber is named myCallback, but it should be named laser callback, yeah, because here in the definition I am setting the callback function to be myCallback, but actually in my code the name of the callback function is laser callback, yeah. So actually, this function is going to never be called. Yeah, the function that is going to be called by the subscriber is myCallback, which is actually not implemented in my code. Yeah, so actually, what I should do is to name this callback function as myCallback, or change the name here to laser callback. Right? So let me do this change. I'm going to save here. Yeah. And then I'm going to recompile my code. Let me come back here and recompile my code. I have done a change, so I'm going to recompile. And this is a pretty stupid error, yeah, of naming one function wrongly and so on. But usually this type of errors are the ones that that are harder to find, yeah, many times. Okay, there we go. Let me source, and I'm going to try to run my program again. There we go. So let me try to run it again. And I'm getting another error. Now it says, laser scan object is not subscriptable. Okay. So this message, specifically, it's a little bit cryptic, okay? Here we can get some more information, but let's repeat again the same process. So let me come back here. Let me copy the code. Copy the whole code now and paste it again to ChatGPT. And let's ask ChatGPT, let's see what it tells us. Find box. Okay, it's taking its time. Okay, there we go. So now it says, all right, there are a few books in the code. And the first one, it says, in the laser callback function, the laser data is accessed incorrectly. It should be message.ranges instead of message. Okay, so here it says, hey, here you should not access the laser value like this. Instead, you should access it like this with message ranges. Okay? And that is right. So again, this is not the correct way of accessing the laser data. Why? Because if we have a look here at the laser scan message, ROS2 interface show geometry, no, sorry, not geometry. It's actually sensor messages. Sensor messages, message, laser scan. Yeah, if you have worked previously with the laser scan, you know that the laser data actually it is provided here inside the ranges array. Okay, so if we want to get the laser readings, the laser values, we have to actually access this ranges array. Yeah, so instead of message like this, we should be accessing this like this, message.ranges. And then we specify the position 359 of this ranges array. Why? Because this position corresponds to the forward laser reading. Okay? Then, as you can see in here, the code assistant is giving us more errors. Okay? But for instance, let's read number 2. It says, in the motion function, the linear velocity should be set to a negative value when the robot is too close to an obstacle. This will make the robot move backwards and avoid the obstacle. Okay? All right, this is not actually a book. Here it's telling us something which maybe we could use or not for our code. Yeah? But actually, maybe we just want to stop the robot and not move it backward. Yeah? So this is actually a book, yeah, because this is making our code, our program, it's causing it to not work, yeah. This not, okay, this is not really a book. It also, for instance, here it says the timer period variable is set to 0.5, which means the motion function will be called every 0.5 seconds. This may not be frequent enough to avoid obstacles at higher speeds. It should be set to, okay, so this is not a book, but it is warning us about possible issues, yeah? So, and yeah, it's telling us many more things, okay? But for now, let's recompile the code and test it now that we have changed this, okay? So, let me come back here, let me recompile the code. And yeah, actually, let me move this a little bit to the left here. Let's put it, yeah. I think here it's okay. All right. Yep, there we go. So we have recompiled. Let me source. And let me run again the program. There we go. Okay, so there we see the robot moving forward. Here we are getting the laser readings. And once this gets below 1 meter, the robot should stop its movement, which is going to be right now. Okay? So the laser has detected that there is something closer than 1 meter, and then it has commanded the robot to stop. Okay? Yeah? So, using, in this case, ChatGPT, we have been able to find the critical bugs in our code and to fix them, okay? Again, this tool, this can be also very interesting for beginners, but let me remind you that this is not perfect, okay? So there are many different types of bugs that you can have in your program and that ChatGPT is not going to detect, okay? For instance, if I copy now the code, let's see what ChatGPT says. Now that I have my updated code, which is working, I'm going to copy it again. Here, click on Find Books. And now, actually, it's telling me there are no books in the code. Okay. But, for instance, I could introduce another type of book. Like, let's say, if my timer, I don't know, if the logic, for instance, I'm going to apply a different logic and say if the laser forward is lower than 1 meter, move forward. And elif self laser forward is higher than 100, then stop, okay? Of course, if I run this code, it's not going to work, okay? In our case, so I can show it to you if you want. Let me put again the obstacle at some distance here. There we go. Let me put it here. I'm going to recompile my code. There we go. So let me source here and run again the code. There we go. Okay, so the robot is not moving, right? It's not working. The program actually it's not working like I want. But if you paste this code, for instance, to ChatGPT, what it's going to tell us? Let's see. Let me paste this code here. And it's telling me that there are no books, okay? So ChatGPT can be helpful in some cases, as you have just seen, but in some other cases, for some errors, it's not going to be able to help you, okay? So again, it is a very interesting tool, a very powerful tool that you can use in your advance, but it's not, it's not going to be able to do all the work for you, okay? So you are going to have to use your brain as well in order to have all the codes working, okay? Yeah, makes sense? Yeah, are you following? There, makes sense, says Soraya. Okay, great. All right, then let's move to the last example, okay? And maybe the one which is more impressive, but also more imprecise, okay? So create code. ChatGPT is also able to create programs for you from zero, okay? We are going to see a couple of examples right now. Then for this, you cannot use the code assistant tool from the construct. So I'm going to actually close it here. For this, you have to actually go to the OpenAI website here. You can click on this link, and this is going to automatically take you there. Let me log in with my account here. Alberto. There we go. Okay, done. All right. Yeah. So in case that you don't have an account, maybe you are going to have to create it, or you can log in with Google as I have just done, okay? But here I'm going to show a couple of examples. Here I have a chat session, which you can see here, which is called Open Class, yeah? Then here we can see the two examples that I have placed here in the notebook, yeah? So this is the prompt that I write, that I ask to ChatGPT, yeah? So I'm telling, write a program for ROS2 in Python to move the robot forward during 5 seconds and then stop, yeah? This is the prompt that I sent to ChatGPT. You can see it here, yeah? Write a program in ROS2 for ROS2 in Python to move the robot forward during 5 seconds and then stop. And here you can see ChatGPT response. It provides me the code, which you can see here. Yeah, and it even explains a little bit how this code works. Okay? Then what I'm going to do is to copy directly the code here from ChatGPT. I'm going to copy it directly, and I'm going to paste it here to this move forward py. Actually, I already have it here, the code from ChatGPT. I'm going to do it again. So there we go. Okay, so here I have the code directly from ChatGPT. Yeah, this is the code, the raw code that ChatGPT, as you can see, has generated for me using this prompt. Then, okay, let me come here and compile. Let me come to the simulation now. I'm going to delete already here the cube with a right click and delete. There we go. Okay. So the code, as I have asked to ChatGPT, as I have asked to ChatGPT, should move the robot forward during 5 seconds and then stop. Okay. All right. So let's see. Source, install setup.bash, and then ROS2 run, GPT tests, move forward node. Let's see what happens. I'm going to run the program. And nothing is happening. Okay. So nothing is happening here. Then we can try, actually I have not tried this, but I'm going to try it now. I'm going to paste this code to the code assistant, and let's see if it tells me something about the code. Copy and paste the code and find bugs. There are no bugs in the code, it's telling me. Okay? You see? Then why it is not working? Well, for this, I have to come in and have a look at the code. Yeah? And if you have a look at the code, you are going to, and you have some experience with ROS, you should be able pretty easily to find the error here. Does somebody spot what is the error here? What is the problem? at least one of the problems because there's actually not only one. Yes, no? Does somebody spot something? No? Okay, so for instance, one of the problems is that it's trying to publish a float64 message into the command bell topic. Yeah? But the command bell topic doesn't use float messages. It uses twist messages, right? So if we do a ROS2 topic info of command bell, we are going to see that this topic uses twist messages, yeah? So we cannot publish float messages. We have to publish twist messages, yeah? So we will need to change this to use twist messages, right? Twist. This should be a twist, this should be a twist, yeah? And then this should be a linear x velocity, okay? We can even decrease a little bit the speed here, 0.5, okay? And the same applies here. So this should be an linear x to 0. Set linear velocity to 0 meters second, yeah? Okay, so we can even create this again. I can try to recompile this. Actually, let me stop compiling everything because it's taking forever. So colcon build packages select GPT tests. There we go. Let me just compile the GPT test package, which is the one that I am testing right now. There we go. Source. And let me run it again. ROS to run, move forward node. Okay, now we can see the robot. It has moved forward, but yeah, so, okay? So if we come here, we can see that there is a strange structure. So it is defining a timer here. Yeah, the structure is not very good, let's say, okay? So what we could do, yeah, so actually this doesn't make much sense. Yeah, it's getting a bit complicated. We could do something like this, just to show a quick, simple example. Let me remove this line. Let me import time here, okay? And then here I'm going to add a time sleep of 5 seconds, okay? Then I'm going to call down here the stop function, okay? Here, stop. There we go. Okay, let me recompile. There we go, it has compiled, source, and run the node. It starts moving forward, 1, 2, 3, 4, 5. And it stops, okay? So what can we, there is another example here, you can check it out. Yeah, this is the first one, which is more simple. Here I asked the following prompt: write a program for ROS2 in Python to rotate the robot 90 degrees using odometry data. Yeah, and it actually created this code here, ChatGPT. Let me show it to you here as well. Yeah, so write a program for ROS2 in Python to rotate the robot 90 degrees using odometry data. Okay, Again, it generates a code, okay, which has some errors in it, okay? We can analyze it. I have it here inside Rotate Robot. But, for instance, here it's trying to publish something, as you can see, but it's not declaring a publisher, actually, okay? So, as you can see, it can generate a structure, an interesting structure, yeah, because here it has generated the class, I have the constructor, a subscriber for odometry, yeah, I have an odometry callback where I am getting the orientation, converting this orientation to yaw, okay, which is very interesting. I have a rotate function, which it is sending to its messages, in this case, to the angular Z. I have a stop rotation function, yeah, my main function. So actually the structure of the code is pretty good as well. Same case as with the move forward, okay? But as you can see, you have to review the code, okay? Even with this one, which is pretty simple, move a robot forward for 5 seconds, then stop, yeah? It had some errors, okay? So you can ask ChatGPT to create you a code for something, yeah? And then you can use maybe the provided code in order to analyze it and to improve it, yeah? But with a starting point already, okay? So this is the idea. You can use it to generate a first version of the code in case that you don't know how to start at all, or you don't want to write everything from zero. You can ask ChatGPT for help, but you have to always keep in mind that you are going to have to analyze the program, okay? Because ChatGPT is going to provide you programs which are not perfect, as you have seen, okay? Also, I can right now send again the same prompt. Actually, I'm going to copy this prompt exactly from here, and I'm going to ask again the same question to ChatGPT. And it is very likely, see, it is very likely that it is going to provide me a different code. Let's see. Well, in this case, it's providing, I think it's providing the same code. Yeah. Let me start a new chat here. Okay, so as you can see, same prompt, and the result is different. See? So now, instead of the class and everything that it was using before, this robot mover, yeah, so now it's directly creating a function here, move robot, with a while here, yeah? So for the same prompt, ChatGPT can produce different results, okay? So you have to also bear this in mind, okay? Yeah? So yeah, this is the message. I'm going to finish the class here. It's already some minutes past the limit time. But yeah, I wanted to show you these examples, provide you some tools that you can use in order to speed up, okay, to help you in your ROS2 learning process, okay? And this can be applied to other things, but in this case, of course, we are focused on robotics and on in ROS2 in this case, yeah. And basically, this is the summary that I would say now to conclude, is that ChatGPT is it's an amazing tool, very, very powerful, and it can really help you if you know how to use it, okay? But you have to bear in mind its limitations, yeah? It has limitations, and you have to know these limitations, okay? Yeah? So, all right, so I'm going to conclude here. Thanks to all of you for being here with me during this class. I hope that you liked it. I hope that you enjoyed it. I hope that you have learned something, and that from now on you can start using this, at least the tool that we provide here, the code assistant that we provide in the construct. And yeah, thanks a lot. I will see you again next Tuesday with another open class. Very interesting. It's going to be about ROS2 security. So stay tuned. And yeah, see you next week. And as always, until then, take care and keep pushing your ROS2 learning. Bye-bye.